Hello, honored algebra students. Mr. Lawrence here, and I'm about ready to cry because this is the third time I've actually made this video. I apologize to those of you I told at the algebra party be ready in a half an hour. Oh, I had the speakers plugged in wrong, so it didn't record my voice. You can see the video, but you can't hear it. So what good does that do you? So we're going to start over. I'm going to try to go fast. All right. I'm going to do 3 of these problems for you. I'm going to start with problem number 2. Or actually, no, most of you have done problem number 2. I'm going to start with problem number 3. Okay, so it says find 2 consecutive even integers. Stop right there. I need 2 consecutive even integers. So my first problem 3, I'm going to define my variables. I'm going to let x equal the first of the 2 consecutive even integers. All right, then the second one will be x plus 2. How do I know that? Because if I count by evens, 2, 4, 6, 8, how am I moving to each one? Well, I'm adding 2 each time. Okay, so it's going to be the second of 2 consecutive even integers. That z with that extra bar in there is a symbol for integers. Okay, so let's see what I need to do with these. All right, 2 consecutive even integers such that if, that's a typo there, the lesser of the 2 integers is squared. So I need to square the lesser one. Well, that would just be x squared. And I don't need parentheses. I could put them in, but it doesn't do anything in this problem. Okay, it is the same as 6 less than 7 times the greater of the 2. Well, is the same as I need 6 less. What do I need 6 less than? 7 times the greater. Be careful. It's not 7x plus 2. I have to multiply the greater of the 2 by 7, which the greater is x plus 2. So I need a quantity there. Now that I've done that, I can go ahead and distribute. And so I will have x squared equal to 7x plus 14 minus 6. Over here, I'm going to simplify. So I'm going to have x squared equals 7x plus 8. Now, I need this to equal 0. How do I know? It's a quadratic. To solve a quadratic, I want a factor, but I want a factor when it's equal to 0. So I'm going to subtract 7x, and I'm going to subtract 8 from both sides. And if you were Leah Bazan, you would tell me that Mr. Lawrence, over here on the left-hand side, I can't put those together. And Leah, you are absolutely correct. So I'm going to write down x squared minus 7x minus 8. And now I'm ready to factor. Okay, I need 2 factors of 8 that subtract to get negative 7. Well, let's see. I could list all my factors of 8, 1 and 8, 2 and 4. I think that's it. What's the subtraction problem? Please, 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 please write down the subtraction problem. All right, well, I think it's going to be 1 minus 8. That equals negative 7, doesn't it? This is important. I'm going to rewrite this as x squared. Now, I'm not going to write negative 7. I'm going to write 1x minus 8x. I think I'm going to put the negative 8 first. Notice my 8 is negative here. My 8 has to be negative here. Then I need a positive x minus 8. I chose to put the negative 8 first, negative 8x, so that I wouldn't need to factor out a negative for my second quantity. You could put the x first, but it still has to be x, positive x, and a negative 8. All right, now I'm going to GCF the first group, and I'm going to pull out an x, and I'll be left with an x minus 8. GCF the second group, I don't see one. So I'm going to leave it as a x minus 8. I'll slap it in a quantity. Looks like I'm pulling x minus 8 out of both parts. I'll have an x minus 8. What's left over? This will turn into plain old x. This divided by x minus 8 would be a positive 1. Oh, that should be an x minus 8 there. Sorry, a positive 1. So let's see here. I solve x minus 8 equals 0, and x plus 1 equals 0. X equals negative 1. I don't like that answer. Why don't I like it? Because I need 2 consecutive even integers. Negative 1 is not an even. I'm going to throw that puppy away. All right, now I'm going to add 8 to both sides here and get x equals 8. Well, if the first integer is 8, the next consecutive even integer is x plus 8, or x plus 2 would be 10. Now let's test it. All right, I need to square the lesser. That would be 8 squared. I need to take 6 less. That's 7 times the greater. Well, 8 squared is 64. 7 times 10 is 70 minus 64 minus 6 is 64. Look, they match. It checks. It works. It's easy. All right, let's do another problem here. Hopefully I'm not going to make this video too long. All right, let's see. Let's drop down here and try number 7. Okay. The length of a parking lot is 20 yards greater than its width. Well, I'm going to draw the parking lot. Okay. To know the length, I need to know the width. By the way, the area of that would be x times the quantity of x plus 20, wouldn't it? All right, let's see what else the story says. The area of the parking lot is 300 square yards. So I am going to take this x times x plus 20 as a quantity. That needs to equal 300. I'm going to distribute and get x squared plus 20x minus 300. How did I do that? I subtracted 300. I should do that in 2 different steps. I'm sorry, I'm getting ahead of myself because I feel like I'm rushing. Slow down, take my time. All right, I'm going to subtract 300 now. Why? Because it's quadratic and I need it to equal 0. So I'm going to have x squared plus 20x minus 300. Now, some of you might see this right away, but I'm going to take a minute to demonstrate the prime factorization method of doing it. I need 2 factors of 300 that subtract to get 20. Well, let's see here. I know that's 30 times 10. Oh, look at that. I got lucky, didn't I? What's 30 minus 10? It's 20. I can stop because I picked the 2 factors that work. So I'm going to do x plus a 30 and x minus a 10. How did I know to use the signs? Well, the 30 was positive. The 10 was negative, right? So there's my 2 signs. All right, I'm going to solve. X is going to equal negative 30 or x is going to equal 10. Ooh, that first answer is bothering me. Can x be negative 30? I don't think so. No way. Doesn't make any sense. So I'm going to throw this one away. I can't use them. So I'm going to say that x is 10 and therefore x plus 20, the other side will be 30. So the parking lot is 30. I think we're in yards, 30 yards by 10 yards. Okay, one last problem. It's a long one. It's problem 11. Looks hard. It really isn't, but I'm going to go ahead and help you with it. Okay. It says a larger square has sides that are 3 centimeters greater than those of a smaller square. Well, I'm going to draw 2 squares. Watch this. I've been practicing my square drawing. Look, check this out. Oh my goodness, look at how good I am. I am amazing. Oh, except I drew 3 squares, but that's okay. We'll just throw him away. All right. Ignore that square behind the corner. Curtain. All right. So the smaller square, the dimensions would be x and x. How do I know? Because I don't know how long they are, which would be an area of x squared. The longer square has an area or a length of 3 more and a width of 3 more. So that would be x plus 3 times x plus 3, which will equal x squared plus 6x plus 9. It's not going to be x squared plus 9, right? It's a FOIL problem. Okay, that's the area of the greater square. All right, so let's see here. What are the lengths of the sides of both squares if the sum of the areas is 1017? Well, I need the sum of the areas, so I need to take x squared. Oops, I'm not in draw mood. Silly me. I need to take x squared, the area of the smaller one, plus the area of the larger one, and that is going to need to equal 1017. I feel like I've made a silly mistake there, but I don't think I have. This is good. So now I'm going to add my like terms, 2x squared plus 6x minus 1008. How did I get that? I subtracted 1017 from both sides, right? Okay, I combined like terms. Now, instead of trying to factor this, I notice there's a GCF in there. I'm going to pull that GCF out. X squared plus 3x minus 504 equals 0. Now I can demonstrate my GCF or my prime factorization method. I'm going to take 504 and I'm going to break it down into factors. Let's see, 4. And if I cut 504 in half, what am I going to get there? 252? Yeah, that's 504. And if I cut that in half, let's see, I'm going to get 126. So 4 times 126 is 504. Okay, and then this is going to break down to 2 times 2, 126. I see that 6 is going to go in. 6 is going to break down to 2 times 3. And 6 is going to go in 21 times. And that's going to be 3 times 7. So the prime factorization of 504 is 2 times 2 times 2 times 3 times 3 times 7. All right, now I need to subtract 2 factors of 504 to get positive 3. Check this out. Check this out. What's 3 times 7? Well, of course, it's 21, right? Okay, this is 21. And what is 2 times 2 times 2 times 3? Well, that's 24, isn't it? 24. What's the subtraction problem that will get me positive 3? It'll be 24 minus 21. All right, now since this lead coefficient is 1, I can just go like this. I can go, you can do it the grouping way if you want. I know Samara likes to do that, and you can. Be a touch longer, but you can do it this way. I'm going to need a positive 24 and a minus 21. I'm going to solve for x. This will never turn to 0. So I'm going to solve this, and I'm going to solve this. This one, the second one will yield the answer x equals 21. And the first one will yield x equals negative 24. Ooh, that bothers me because if I have an area or a length of negative 24, that doesn't make any sense to me. Doesn't make any sense. So x has to be 24, I believe. And then this one has to be, oh, did I do that right? No, x has to be 21, excuse me. 21, and this is 21. And then therefore these are 24 by 24. Now let's check it. Let's square them both and add them up, because that's what it says. We have to get 1017. Well, I have 21 squared plus 24 squared, and that'll equal 1017. If it does, I did it right. Well, this is 441, and this is 576. And I'm a vertical kind of guy, 441, 576. And if I can add them together, I'm going to get 7, I'm going to get 1, and I'm going to get 1017. Look at that. They match. All right, that's it. I did 3 problems for you. I gave you the answer key. Good luck tomorrow. Mr. Lawrence signing off. Good night, everybody.